Hello guys, my name is Simon and welcome to another video on ALS software engineering program. Today we'll be looking at the C pointer array and string. This is one of the most building block of C, and it's very important you actually understand how C pointer array and string works. So I'm going to try my best to make sure I explore some examples so that we can have a concrete understanding on how it works. So first of all, let me open this link, the link under the concept which says pointer and arrays. So I'm going to open that in a new tab. I expect you to read everything, but what I want to do is to pick out some examples here. So in this section it says type and memory. One thing I want you to note is every data type has its own memory size. Here you can see for character it has 1 byte. For integer it has 4 bytes. For float it has what? 4 bytes. You can also get the value when you use this size of character, size of integer, size of float. However, let us copy this code and let us run it so that we can see the exact result. So I'm going to copy this and go to my online C compiler, which is programmist.com. I'm going to remove the default one and paste this. The next thing I will do is to click on the run button, and you can see the results at the right hand side. So the size of type of character in my computer is 1 byte. Size of type of int in my computer is what? 4 bytes. And the type of float in my computer is 4 bytes. Size of type of my variable on my computer is 4 bytes. So we can see the variable declared on line 11 here is an integer, and of course we've also print out the size of an integer, which is 4 bytes. Okay, let me go back to this. Another section I want you to pay attention to is pointer. Okay, I'm looking for that example. It's pointer. Okay, let me scroll down a little. So on this section, here is the referencing. I'm going to copy this and use this for an example. So I'm going to copy from here and do Ctrl C and Ctrl V in my online compiler. Okay. So one thing I want you to notice is on line 10, a variable of type integer was declared. On line 11, a pointer was declared. And on line 13, the value 98 was assigned to the variable n. And on line 14, you can actually pause the video and guess what is happening here. Okay, let me just show you. So this, what is happening there is called dereferencing. If you go back to the code again and look at line 14 very well, you can see the value of n as the ampersand and n. This is assigned to p. The ampersand n is giving access to the memory location of n. So p is now holding the memory location of n. So let us run the code and see what we get. When we run the code, you can see on the console the first value, which is the value of n, is 98. You can remember that was assigned on line 13. Then the second line is address of n is what? This highlighted here, the address of n, and you can see this is coming from line 16, which you can see we're using the ampersand sign and n, which is, it gives us access to the address. Then since we've assigned the memory address of n to value p in line 14. Then we want to also print the value. So on this section, here is the referencing. I'm going to copy this and use this for an example. So I'm going to copy from here and do Ctrl C and Ctrl V in my online compiler. Okay. So one thing I want you to notice is on line 10, a variable of type integer was declared. On line 11, a pointer was declared. And on line 13, the value 98 was assigned to the variable n. And on line 14, you can actually pause the video and guess what is happening here. Okay, let me just show you. So this, what is happening there is called dereferencing. If you go back to the code again and look at line 14 very well, you can see the value of n as the ampersand and n. This is assigned to p. The ampersand n is giving access to the memory location of n. So p is now holding the memory location of n. So let us run the code and see what we get. When we run the code, you can see on the console, the first value, which is the value of n, is 98. You can remember that was assigned in on line 13. Then the second line is address of n is what? This highlighted here. The address of n, and you can see this is coming from line 16, which you can see we're using the ampersand sign and n, which is, it gives us access to the address. Then since we've assigned the memory address of n to value p in line 14, then we want to also print the value of p. You can see the signature here. It says %p%p. So if we run that, and you can see the value of p is equal to the memory location of n, which that is correct. Another thing you can see is the manipulation here. So you can see we are using the memory location on line 18 to manipulate the value of n, because since we are holding the location, right, since we are holding the location, we're going to manipulate the source of that variable. And now if you print the value of n, the value of n is now equals to 402. Okay, the two things I want you to take away here is this part, right? This part is where the dereferencing is taking place. Then on line 18 here, it is where we are using the pointer to manipulate the value of n. So it's just like n is a variable and n is stored in a source s. Okay, so in this source s, the value p, which is a pointer, right? So p here, p is not pointing to n. Okay, p is pointing to x. So what is going on is, if we change the value of s to 402, right, to 402, just as we've done in line 18, okay, what will now be the value of n is what? 402, since they are drawing from the same source. Okay, so that's for that. So I'm going to clean this off. I'm going to look into more basic example. Just a quick word before I move to the next example. One thing I want you to know is the percent %p, it gives you the memory location of that element. All right, you can see that here on the format specific, right? So if you scroll down, you can see percent %p, it prints the memory address in the hexadecimal form. We also have x, which is the hexadecimal number. So if you go to your compiler, you can replace p with x, and you run. You can see this is the hexadecimal number. Why p? It gives us what? The memory address in the hexadecimal form. All right. When we talk about an array, let me give some basic example of an array. So to declare an array, the first thing you need to do is to declare a type, the data type of the array. Then you can declare the variable name. Then you put a square bracket. For the square bracket, right, you want to impute the number of length your array should hold. So for example, mine, I want you to hold 3 items. So for these 3 items, right, you can decide to leave it here, right? You can put your semicolon and later go ahead to add value, or you can just assign the value right here. So let me say, for example, right, mine is to hold 3 items, so I can do 2 as the first one, then 3 as the first one, and 6 as the last one. Okay. While replaying this video, I discovered some parts of the video were not recorded, so I'm going to just roll back and do some little example on that. Okay, so let's go. You can see I have declared a variable called integer. This is an example, right? The name of the identifier is what? Example, and the type is an integer. So this is an array to hold 3 items. One thing that's very important is arrays are stored from 0. So if you are specifying 3 items as your array container, it's going to start from 0, followed by 1, then followed by 2. So if you want to access the item in the first index, so all you're gonna do, printf, let me just do value, then %d, this is n, then %t, and you're gonna do example of 0. So this should print out the item in the first index. So you can see this is the item in the first index. I specify 0 as the index, just as you've seen here. 0 as the index, and it points to the first item. So if you want to print out the last item, you should know this is index 0, index 1, and index 2. So what you should specify is what? Index 2. And if you run, you can see we're having 6, which is at the 3rd index. Alright, so let me go to some basic example using a string. So I'm going to change this to a character. Then my character should be 3 items. So for the character, I want to print out my name, and the next thing I want to do is to print out the item at the 2nd index, at the 3rd index, which is index 2. So for that, our percentage should be what? %c. So I think everything is okay. Let me run. If I run, you can see I am getting what? M. If you want to print the item in the 4th index, all you need to specify it in the example index here is 0. And if you run, you can see it prints out 0. Okay, so what if you want to print out everything? To print out everything, you can just remove this, remove the no, you can still leave this, all you need to do is to specify here as %s. Then if you remove the index specifier here and run, you can see it's printing out the 3 items, because I have specified that my array should hold only 3 items. But what if I decided to say I want 8 items? If I run, you can see it's printing 8 characters from the array. Then what if I say I want 12 items? If I run, you can see it prints out everything. However, you can still remove your limitation here, which is the array size. You can remove it, then the array will not have a size, so it can print out everything you specify here. You can see, let me run this, and you can see it prints out everything. Okay, let me remove this. In some cases, you want to print the whole string itself. So the first thing you should do is to change this formatter from C to X, and you need to remove this array index, then run. You can see it prints out the whole text. Okay, but what if you specify that you want to put only 3, you want to have only 5 item, right? So you can see if you run, your array is going to pick only the first 5 item. If you run this, you can see it pick out the 5 item. What if you change it to 8 and you run? You can see it picks out the first 8 item. So that is basically how an array works. With the few examples I have given so far, I hope this give you some clarity on how C, pointer, and array work. The best thing you can do for yourself is to practice, read the resources. You can look at most of the examples here. You can practice on your own, manipulate it, play around with it, and you are going to get more ground and more understanding on how C and arrays work. So now we want to work on the project. So if I go to the project, and the first thing I want to do is the quiz section. So welcome to the quiz section, and what I will do is to scroll down so slowly. I'm going to scroll down slowly, so if I'm too fast, you can pause the video and get it right. But make sure you study your resources and everything you need to know before you can attempt this quiz section. So I'm going to scroll down little by little. I'm going down little by little. This is quiz 2, question 2, quiz 2, question 3, under quiz question 4, under quiz question 5, under quiz question 6, under quiz question 7, under quiz question 8, under quiz question 9, under quiz question 10, under quiz question 11, and under quiz question 12. All right, so let me minimize this so that we can work on the task section. Okay, good. So the first thing you want to do in the task section is to log into your terminal. Okay, so let's make like this. Okay, let me zoom in. Let me increase this. Okay. All right, so the next thing I want to do is to log into my terminal. So I'm going to go to the terminal section, the sandbox section, and right click on new tab. Then so you can use, there are 2 ways you can log into your terminal. You can use the web terminal, which is this, but I'm not going to use that. I just click on the SSH here. So I've clicked on it. Then I put that here. SSH. Remember, you don't need to use mine, you already have yours. So SSH, and it's prompting for password. What I will do is to go to my password section and click on copy. You can see it has been copied. Go back to my terminal, right click and paste. If you paste, it will not show, but you just press enter. Okay, permission denied. So I'm going to right click again, paste, enter. Okay, good, I'm in. So if I log into root, I want to locate my project folder. Then it should be ALS, low level programming. Okay, so the first thing I want to do is to go back to my project folder, sorry, my project URL, and look at the repo here. It says this is the repo and this is the directory. So what I will do here is to create this directory. So I'm going to do Control C. I'm going to do Control C and create that directory. So to create a directory, I'm going to do mkdir. Then we've copied the directory name. I'm going to paste it and enter. Okay, cannot create directory because it already exists. So what I will do is to navigate into the directory. Yeah, so for that, this is 005 pointer underscore array underscore string. Okay, so let me check what I have inside. Okay, I already have this. Okay, all right, so let me use my example section. So I'm going to clear my screen here and go back. Okay, sorry, without any confusion, what I'm going to do is I'm going to use my example folder, right? So let me just see if I can access that. Okay, good, I am there. Here, let's low level programming. So I'm going to run that command again. I think I still have the name of the folder. Good. So I'm going inside that folder now. Good. So if you check, you can see there's nothing inside. The first thing we want to do is to create our readme file. So I'm going to create my readme file, readme.md. So I want to write something in it. It should not be empty, and I will just do pointer and array project. Escape, regular colon WQ, enter. If you check now, you can see we now have the readme file. Okay, so if you go back to the browser, and read the first question. So it says write a function that takes a pointer to an integer as a parameter and update the value of its pointer to 98. Okay, so we are given a prototype here. So the first thing we need to do is we need some properties here. So we need this file underscore pucha.c, and we also need main.h, which should hold all our header, sorry, all our prototype. Okay, so let me go back to the terminal. Okay, so for that, I don't want to waste your time. I'll just copy what I already have. So we need this header. Sorry, we need this prototype, right, in our header file, which is the main.h. So let me copy the one I already have. So you need to put that file there. So I'm going to copy that. Okay, I want to copy the picture first. So if it should be ox-3, if this is ox-5, okay, then underscore picture dot c and put it here. Then I also need the header file, so I'm going to copy that from my previous project. I'm going to copy that, then one step backward. I think this should be, sorry, this should be root. Okay, this is not root. Okay, sorry, let me just see. Sorry, let me pause the video and I'm gonna be back. I want to locate the folder. I don't want to waste your time. I'll be back when I locate the folder. Thank you. Okay guys, I'm back. So I discovered I have to move like 4 steps backward. So I'm gonna do my copy now. Copy. I think I should have access to root now. Okay, one more step, dash root slash alx low level programming. Then in o dash, sorry, it should be o dash o dash 5 and it should be main.h. I want to copy that in my current folder. So let me clear. So if I clear that and I list what I have here, so I have my main.h now. So in my main.h, I want to see what is there. So you can see mine is already updated. So if you look at what we have here, it says void reset to 98. You can see I already have that here, which is void reset to 98. So all you need to do, you can decide to update it one by one, or you can decide to update everything. So if we go back here, what you want to do is to create this file for your testing. You want to make sure your file is working. So I'm going to do Ctrl C and use my Vim to create this file. Okay, then I'm going to copy what I have here. Ctrl C and press my I. For the I, I'm going to right click and click paste. Okay, so I'm going to do escape regular column WQ. So that is our testing file. All right, so the next thing I want to do is to create this file, which is o-reset to C. So I'm going to copy the name of that file. Instead of just writing that again, I already have that, so let me just copy what I have here. So I'm going to copy, let me look at the name again. So o-reset o-reset.c. so if I clear and I do ls-l, you can see I have mine here. So when you are done writing your own file, you want to check if Betty will complain or not. So you can do yours o-reset and run Betty on it to see if everything. So you can see mine is okay, there is no error. So the next thing you want to do is to test your file if it's okay. So you want to run the test, you want to compile and run, Ctrl C and paste it here. So when you paste it here, you press enter. When you press enter, you can see there is no error. But note, if you do ls-l, you can see there's a new file called 98. The file is executable, so you can do slash o-98 and press enter. So you can see it gives us a result. And if you look at the result we have here, you can see it's basically the same thing. So that shows you've completed the task. So all you need to do is to do your git status, git add, git commit -m completed task. And next thing you want to do is to do your git push. Okay, I don't want to push, so I'll just leave it here. Okay, so this is just like a basic step you will follow to work on your project. I don't want to waste your time. I think that is just one example is okay for this. Okay, so that is all. So I'm going to share a link on the description to my source code. You can look at it, you can modify it. Mind you, you don't need to copy. You need to look and write it yourself. If you do copy and paste, it's not going to work. They're going to detect that you are actually doing copy and paste. But if you write it, it shows that you're actually working on their platform. So that is all for this video. Thank you very much. I'll see you in another video.